Hello and welcome to Cosmic Queries, the book club. I'm Alexa.
And I'm Sam. Today, we're embarking on a very special journey. We're not just discussing a book, we're discussing a phenomenon. A book that, for millions of people around the world, was their first real introduction to the universe, not as a cold, empty place, but as a home.
That's right. We're talking about Carl Sagan's Cosmos, first published in 1980 alongside the legendary television series. This book is more than a summary of the show. It's a deep, poetic, and profound exploration of everything. The subtitle says it all: A Personal Voyage.
And what a voyage it is. Sagan takes us from the infinitesimally small world of atoms and DNA to the grandest scales of galaxies and the cosmos itself. He weaves together astronomy, biology, history, and philosophy, all with this palpable sense of wonder. So, our goal today is to unpack this masterpiece. We'll walk through its key themes, its most powerful stories, and ask why, over 40 years later, its message is more urgent than ever.
We'll start with that iconic opening line, which really sets the stage for the entire journey.
The cosmos is all that is, or ever was, or ever will be. Just sit with that for a second. It's not a scientific statement filled with data. It's a philosophical pronouncement. It's vast, it's inclusive, and it's final. It immediately pulls the reader out of their daily concerns and says, look, this is what we're a part of. This is the big picture.
And that, I think, is the core of Sagan's project, instilling what he called the cosmic perspective. The book is an exercise in scaling up our imagination. He wants us to feel the sheer size of the universe, not to make us feel insignificant, but to make us feel connected. The first chapter, The Shores of the Cosmic Ocean, is all about this.
Let's talk about that scale. How does Sagan make the unimaginable unimaginable?
He's a master of the analogy. He starts with the familiar, Earth. He describes it as a place of great sand-green seas and land masses. Then he zooms out. He introduces the concept of the light year, the distance light travels in a year, about 6 trillion miles. And then he begins the journey.
He takes us on what he calls the cosmic calendar. This is a brilliant pedagogical tool. He compresses the entire 13.8 billion year history of the universe into a single calendar year. So the Big Bang happens at the first second of January 1st.
Right. And on this calendar, our Milky Way galaxy forms sometime in March. The Earth doesn't even condense out of cosmic dust until mid-September. Life, the first simple organisms, appear around September 25th. The dinosaurs ruled the Earth from about December 25th until December 30th.
And humans? All of recorded history, every war, every empire, every discovery, every love story, fits into the last few seconds of December 31st. It's a breathtakingly effective way to illustrate the profound depths of cosmic time and our very, very recent arrival on the scene.
It absolutely recalibrates your brain. You realize that the universe was going about its business for billions of years before we showed up. But then, Sagan immediately follows this with his most famous idea, which brings us right back into the center of the story in a different way. Alexa, you know the one.
How could I forget? The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies, were made in the interiors of collapsing stars. We are made of star stuff. That's the beautiful pivot. The cosmic perspective isn't about making us feel small. It's about making us feel woven in. We are not separate from the universe, looking on from the outside. We are the universe, a part of it that has become self-aware. The atoms that make us up were forged in the nuclear furnaces of stars that lived and died long before our sun was born.
It's a profound statement of kinship with the cosmos. It's also solid, hard-nosed astrophysics. Sagan explains the process so elegantly. The early universe, after the Big Bang, was mostly hydrogen and helium, the two simplest elements. There was no carbon, no oxygen, no iron, so where'd they come from?
From the stars themselves. Stars are fusion reactors. They smash hydrogen atoms together to make helium, and that process releases the energy that makes them shine. For most of a star's life, that's what it does. But for more massive stars, when they run out of hydrogen, the core contracts, heats up even more, and starts fusing helium into carbon, and then carbon into oxygen, and so on, all the way up to iron.
And then the star dies. In a spectacular supernova explosion, the star blasts these newly forged elements out into the cosmos. The incredible heat and pressure of the explosion itself create elements even heavier than iron, like gold and uranium. This stardust then mixes with clouds of gas and dust, which eventually collapse to form new stars, but now surrounded by planets rich in these heavier elements.
So our solar system, our Earth, and everything on it, including us, is made from the ashes of earlier generations of stars. We are literally the universe's way of knowing itself. This idea is the emotional and scientific heart of Cosmos. It connects the grandest cosmic processes to our most intimate existence.
And from this foundation, Sagan pivots to the tool that allows us to know all of this, science. But he presents science not as a dry list of facts in a textbook, but something much more dynamic and human.
Exactly. For Sagan, science is a method. It's a way of thinking, a candle in the dark, as he would later call it. It's a continuous, self-correcting process of inquiry. It's about making observations, forming hypotheses, testing them, and being willing to abandon your most cherished ideas if the evidence doesn't support them. He contrasts this with dogma, which claims to have all the answers and refuses to change. Science, by its nature, is humble. It says this is our best understanding based on the evidence we have right now, and that understanding can and will change with new evidence. It's a journey of learning and discovery, not a destination.
And to illustrate this, Sagan takes us back in time. He goes to a place that, for him, represented one of the great turning points in human history, the Library of Alexandria.
This section of the book is both triumphant and tragic. The Library of Alexandria in Egypt was perhaps the greatest repository of knowledge in the ancient world. It was a university, a research institute, and a library, all in one. Scholars from all over the Mediterranean came there to study, to debate, and to advance human understanding.
Sagan introduces us to one of its librarians, Eratosthenes, and he tells the story of how Eratosthenes calculated the circumference of the Earth with remarkable accuracy around 240 BC. It's a story that perfectly encapsulates the scientific method in action.
The story goes like this. Eratosthenes heard that in the town of Syene, modern-day Aswan, on a certain day of the year, the noon sun would shine directly down a deep well, illuminating the bottom. This meant that the sun was directly overhead. But in Alexandria, on the same day and at the same time, vertical objects cast a shadow.
So he reasoned that the Earth's surface must be curved. If it were flat, the sun would be at the same angle everywhere. Then he did a brilliant piece of geometry. He measured the length of the shadow cast by a vertical stick in Alexandria. Using that, he calculated the angle of the sun's rays to be about 7.2 degrees off of vertical.
Now, 7.2 degrees is about 1/50th of a full circle, 360 degrees. Eratosthenes knew that Syene was roughly due south of Alexandria. He assumed the distance between the two cities was about 500 miles. The unit he used was stadia, but will convert. So if 7.2 degrees of curvature corresponds to 500 miles, then the full 360-degree circumference of the Earth must be 50 times that distance, about 25,000 miles.
And he was almost spot on. The actual circumference is about 24,901 miles. This was an incredible feat of reasoning. With just a stick, the power of observation, and some clever math, a man over 2,000 years ago calculated the size of our planet. For Sagan, this story is a testament to human ingenuity. It shows that the scientific spirit was alive and well long before the modern era. But then comes the tragedy. The Library of Alexandria was destroyed. It suffered a series of fires over centuries, likely starting with Julius Caesar's accidental burning of a warehouse district, and culminating in religious conflicts that saw it targeted as a symbol of pagan knowledge.
Sagan describes the destruction not just as the loss of buildings and scrolls, but as a catastrophic amnesia for the human species. The knowledge contained within, the works of Aristarchus, who proposed a heliocentric solar system, of Hero, who built a working steam engine, of so many others, was lost for over a millennium.
This leads to one of Sagan's most poignant reflections, the fragility of knowledge. Civilization is not a guarantee. Progress is not inevitable. He asks us to imagine how different history might have been if the science of the Alexandrian Library had been preserved and built upon. Could we have reached the stars centuries earlier?
The story of the library serves as a warning. It reminds us that the light of knowledge must be actively guarded and passed on. It can be extinguished by fanaticism, by apathy, by simple accident. This theme of lost knowledge and the importance of preserving a scientific, rational worldview is a thread that runs throughout the entire book.
From the origins of knowledge, Sagan then turns to the origins of life itself. He takes the same evidence-based approach, connecting the cosmic star stuff to the biology of our planet.
He begins with the early Earth, a violent, molten world bombarded by asteroids and comets. But within those comets and in the primordial atmosphere of Earth, the building blocks of life were present. He discusses the famous Miller-Urey experiment, where scientists simulated early Earth conditions in a flask with water, methane, ammonia, and hydrogen, and zapped it with electrical sparks to simulate lightning.
And what happened? Within days, the clear water turned a murky brown, and analysis showed it was filled with amino acids, the fundamental building blocks of proteins, which are essential for life as we know it. This experiment demonstrated that the organic molecules necessary for life could arise naturally from the chemistry of the early planet.
Then Sagan takes this a step further into space. He was deeply involved in the field of astrobiology. He points out that complex organic molecules are found in interstellar gas clouds, in comets, and on other worlds. The universe, it seems, is brimming with the ingredients for life. The transition from these non-living organic molecules to the first self-replicating system, the origin of life, is still a mystery. But Sagan presents it as a plausible, perhaps even inevitable outcome of cosmic and planetary evolution.
And once life begins, the next great engine of change kicks in: evolution. Sagan devotes significant time to explaining Charles Darwin's theory of evolution by natural selection, and he does it with his characteristic clarity.
He breaks it down to its core principles. First, variation. Individuals in a population are not identical. They have variations in their traits. Second, inheritance. These traits can be passed from parents to offspring. Third, selection. Because resources are limited, there is a struggle for existence. Individuals with traits that are better suited to their environment are more likely to survive and reproduce.
Over generations, these advantaged traits become more common in the population. The population evolves. It's not a random process, it's a filtering process. The environment selects for the most successful variations. And this process, operating over billions of years, has produced the breathtaking diversity of life on Earth, from bacteria to blue whales.
But Sagan knows that abstract principles can be hard to grasp. So, he gives us a concrete and fascinating anecdote, the story of the Japanese Heike crabs.
This is one of the most memorable anecdotes in the book. The Heike were a powerful Japanese clan who were defeated in a great naval battle, the Battle of Danoura, in 1185. According to legend, the spirits of the drowned Heike warriors were reincarnated as crabs.
And indeed, there is a species of crab, the Heikegani, whose shell bears a pattern that uncannily resembles the face of a scowling samurai. For centuries, fishermen who caught these crabs would throw them back into the sea out of respect for the Heike spirits.
Sagan, with the science's eye, offers a different explanation. He proposes that this is a beautiful, unintentional example of artificial selection, a form of evolution guided by human choice, similar to how we've bred dogs from wolves or corn from a wild grass.
The idea is that long ago, there was a natural variation in the shell patterns of these crabs. Some patterns might have vaguely resembled a human face. Fishermen, perhaps superstitiously, were more likely to throw back the crabs that looked face-like. The crabs that didn't look like faces were eaten.
So, over many generations, the crabs with the most samurai-like patterns had a higher survival rate. They were more likely to reproduce and pass on their samurai-faced genes. Gradually, through this unconscious human selection, the pattern became more and more pronounced, until we have the crabs we see today.
It's a powerful story because it connects a cultural legend to a fundamental biological process. It shows that evolution isn't just something that happened in the distant past. It's happening all around us, and we are active participants in it. It makes the concept of natural selection tangible.
And this leads to Sagan's crucial point about our own species. He applies the principles of evolution to humanity. He talks about the role of mutations, random changes in DNA, as the source of variation. And he discusses how our traits, from bipedal walking to our large brains, were shaped by the selective pressures our ancestors faced on the African savanna.
But he also highlights a critical turning point, the development of culture. For humans, cultural evolution began to operate alongside, and in some cases faster than, biological evolution. The ability to learn, to use language, to pass on knowledge not just through genes, but through teaching, radically accelerated our ability to adapt.
This brings the narrative full circle, back to the Library of Alexandria. Culture and knowledge are our species' most powerful tools. They are the legacy we build and pass on. But as the library's destruction showed, they are also terrifyingly fragile.
This sets the stage for the final part of Sagan's voyage. He looks to the future. He explores the possibilities of space exploration, of searching for life beyond Earth with projects like SETI, the search for extraterrestrial intelligence, and of one day becoming a spacefaring civilization.
The famous pale blue dot image, though from later in Sagan's life, perfectly captures the spirit of this section. The photograph taken by the Voyager 1 spacecraft from beyond the orbit of Neptune, showing Earth as a tiny, pale blue speck suspended in a sunbeam.
And Sagan's reflection on that image is the ultimate expression of the cosmic perspective. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. Every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam.
It's a message of both humility and unity. From space, there are no borders. The book is a plea to use the gift of our intelligence, our science, to overcome the tribal divisions that threaten us, to cherish and protect our fragile world, the only home we've ever known.
And that's the enduring power of Cosmos. It's not just a book about facts, it's a book about meaning. It provides a scientific basis for a sense of wonder, for a feeling of connection to the universe. It argues that science, with its values of skepticism, curiosity, and open-mindedness, is not opposed to spirituality, but can be a profound source of it.
Sagan closes his journey by reflecting on who we are. We are a way for the cosmos to know itself. We are star stuff, pondering the stars. And our future, for better or worse, is inextricably tied to our continued exploration of that cosmos, both outward into space and inward into the workings of nature and ourselves.
In a world that often feels divided and fraught with peril, the message of Cosmos is a beacon. It reminds us of our shared origins on a pale blue dot and of our potential, if we can only embrace reason and wonder, to create an extraordinary future.
Well said. That's all the time we have for today. Thank you for joining us on this journey through Carl Sagan's Cosmos.
Join us next time on Cosmic Queries, the book club, where we'll be diving into another classic of science and speculation.
Until then, keep looking up. Don't forget to subscribe, like, and share. Bye-bye.